Hello students, this is Mr. Boggs here. I've just completed the videos on section 4.1 of our textbook. So now we're going to have a look at section 4.2, which is the inverse of y equals x squared, which is x equals y squared. Okay, so here's a picture of the two graphs. So here's our standard quadratic equation, y equals x squared. And here's the graph of x equals y squared. And as you can see, that has the same shape. It looks like it's been rotated 90 degrees. But a better way to think about it is if you think of that graph being there, a mirror being right there along the line y equals x, and the reflection of that becomes that. So in general, with inverse functions, you just reflect the graph across the line y equals x, and you'll get the graph of the inverse function. And if you notice the coordinates, right here, the coordinates of that point are -2, 4, and the corresponding point in the inverse function is 4, -2. So basically what's happened is we've just swapped the x and y coordinates. Okay, let's move on and do something with this. Okay, to find the inverse of a function, all we have to do is just swap the x and y coordinates. So there's the the equation for a quadratic equation, y equals x squared. So my suggestion is pause the video and see if you can rewrite that equation so you have x equals. And let's see what you came up with. So first we just swap x and y, and now we have to make this y the new subject. So y squared equals x, just swap the two to put the y on the left, and take the square root. And the important thing is to realize you actually now have two functions, y equals positive square root of x and y equals negative square root of x. And that of course is because both positive times a positive gives you a positive, and a negative times a negative gives you a positive. So in fact we have two different solutions. So there they are right there. And moving on. Okay, let's have a look at just a table of the function y equals square root of x. This is straight from the textbook. So what is the domain of the function f of x equals square root of x? Well, basically because x is underneath the square root sign, x can be 0, but it can't be negative. It can be 0 or positive, but it can't be negative. So therefore the domain of the function is 0 up to positive infinity. Or you could also write it as x is greater than or equal to 0. And there's an example of some values for that particular table. So for example, when x is 25, square root of 25 is 5. Okay, let's have a look at some of the exercises. Again, what I'm suggesting that you do with these is have a go yourself first. So pause the video, read the question, try to answer it, and then restart the video to check your answer. So consider the relation x equals y squared plus 1. Part A, complete the table of values, and hence sketch the graph of the relation, and determine the coordinates of the vertex and the equation of the line of symmetry. So stop the video and have a go. Okay, so here's my solutions for that. See if you agree with those. So for example, when y equals -3, -3 squared is 9, plus 1 is 10. So when y is -3, x is 10. Notice that when y equals +3, we get 3 squared is 9, plus 1 is 10 as well. And when you draw the graph of that, you get the graph that we showed on the opening page of the second page of this chapter. Okay, so that, by the way, is not a function if it doesn't pass the vertical line test. If you remember the vertical line test, if you draw a vertical line anywhere where the x coordinate exists, such as there, if you get more than one value, oops, let me try my correct pen. If you get more than one value of y, you have a relation, but not a function. So that's not a function. Okay, determine the coordinates of the vertex. Well, there they are right there, so that's pretty easy. That is just x equals 1 and y equals 0. And the line of symmetry is obviously the x-axis, and the formula for that is y equals 0. Okay, moving on. Okay, here's a little bit of a challenging question, not too bad. So again, stop the video, read the question, have a go, and then check your answers. So the shape given in the diagram is made up of 6 squares of side length x centimeters. Construct a formula for x in terms of the area of the shape a centimeters squared. And then sketch a graph of x as a function of a. Determine the value of x correct to 2 decimal places when the area of the shape is 20 square centimeters, and confirm the answer from your graph. Okay, so stop the video, please, and have a go. Okay, so to start with, let's write the equation where x is a function of a, because that's pretty straightforward. Each of those squares has an area of x squared, and there's 6 of them. So the area equals 6 times x squared. And now we just have to make x the subject. So divide both sides by 6 and take the square root, and x equals square root of a on 6. Notice that we don't have a negative answer there, and that's because you can't have negative lengths and you can't have negative areas. So mathematically speaking, it should be plus or minus square root of a on 6, but practically speaking, it has to be the positive value. Okay, moving on from that. Okay, so a is on the horizontal axis. So notice in this case, x is actually vertical, not horizontal, which is unusual. So let's get a couple of points that actually lie on the graph. So when a is 0, x is 0. And when a is 6, we get 6 divided by 6, which is 1. Square root of 1 is 1. So that gives us 2 values, 2 coordinates that lie on the graph. And there's my beautiful sketch just there. So it passes through 0, 0, and it also passes through the point 6, 1. Okay, part C. Determine the value of x correct to 2 decimal places when the area of the shape is 20 square centimeters. Well, this one, if you've tried it, hopefully didn't find it too difficult. There's the equation. All we have to do is substitute in 20 in for a and work out the answer on the calculator to the nearest 2 decimal places. And I'm not going to draw the graph of this one. My suggestion is draw the graph on your calculator, and you can use your calculator to confirm that answer. Okay, and moving on. Okay, this is the last question in the first video. So read the question, have a go. It's not too difficult. We're only going to do question B. Question A is very straightforward. Even B is not that difficult. For a particular type of material, the formula for the diameter, d, in centimeters of rope needed to lift a load of mass m tons, is given by this formula just there. And determine the mass that could be lifted by a rope of diameter 1.5 centimeters, and round your answer to 2 decimal places. So stop the video and have a go, please. Okay, so pretty straightforward. Obviously the 1.5 is going to go in place of d and not m. So that's the first stage. Oops, there's the first stage right there. D is equal to 1.5. Divide both sides by 0.5. 1.5 divided by 0.5 is 3. So the square root of m is 3, and therefore m is 9, and the units are tons. And that's the end of the first video.